Hey Bailey, where are you? We need you. And we're sorry that you're not here today. If you're not feeling well, we've prayed for you and we just hope that you are up to watching this class. Does it seem to be, that's my phone, isn't it? Does that mean something?
Probably.
All right, well, I don't care. It can be. All right. We have already titled our paper, so you can catch up with us. It's Volumes of Solids of Known Cross Sections, which means nothing to you at this point. So, but in a minute, that will make a lot of sense. This is our last idea of volumes. Like we have done volumes by discs and washers and shells, and now we're going to do a slight twist on that. So, here we go. I'll teach it by example. I'll probably do 2, and then you'll be off to the races. So, all right. Let's establish, we're going to take this function, y equals x plus 1, and y equals x squared minus 1. Excuse me. And we're going to find that area first. So if you would draw a fairly large picture this time for your first one, like a third or quarter of your page, and x plus 1 will cross at the y-axis at 1 and have a slope rise over 1 of 1 over 1. So here we've got this line, it's linear. And then we have the parabola, the smiler moved down 1. So regular parabola like that, something like that. So we always need to know the the intersection points. So I noticed that this one intersects at -1, and I'll let you do the algebra when you have to do your own problems. You're just going to set these two functions equal and solve them for x, and it happens again at x equals 2. So not taking extra time on that, you are algebraically prepared to do that on your own. So I put in the intersections, the x values of the intersection points, and now what I'm going to do is I'm going to create a figure from this area that's bounded by these two curves, and this figure is going to have cross sections that are squares which are perpendicular to the x-axis. And this is where my drawing really falls short, but on the handout that I will shine the projector on the camera on in a minute, maybe it'll look a little clearer, but I'll do the best I can. So what's happening here is we're building a figure from this base, and every cross section that is perpendicular to the x-axis, if I cut it and lift it out and turn it over and show it to you, it's going to be a square. So don't draw this on your paper, just watch me for a minute. Alright, so I'm going to take, say, this part right there, and that is perpendicular to the x-axis, and this is one side of the square. It's sitting flat on this planar figure here. Now coming out of the board towards you, which I'm going to draw it a slant for perspective, is a square. I don't know if you can imagine that as being a square that's it's actually coming straight towards you out of the board. Now, there are squares like this that march across this whole figure. So there's one way down here as well. I'll switch colors. But look, that's a tiny square, and it's one side of it is only that big, so it's a little square. Then there's a tiny, whiny one, like even to the left of that. So can you imagine filling up this whole figure with different squares like this? I'm running out of colors here. Alright, so here's another one. I'll put another red one in like this. So now let's connect all the edges of our squares, and we actually have a 3D figure. It's really difficult to draw. So I'm going to rewrite this with just the one square, but if I'm filling up this base with squares that come towards you, it will create a three-dimensional figure. All right. All right, so drawing that again, there's the line. Here's the parabola that's been dropped 1, and here's the planar figure. All right, so to find the volume of such an animal, we're going to start with 1. Now you can draw on yours. I want you to draw in just that base of the square, and it's going to come out towards you. See if you can draw one square that kind of rises up from that base toward you, actually. So that's one cross section. So we're going to have an infinite number of those. So we're going to sum them up with our integral. Does that catch on the board? You can kind of move it or tilt this whole thing over to get it better. All right. Thank you. So to sum all of them up, I'm going to go from the x value of -1 to 2, and we are going to have to find the volume of just one of these cross sections, and then the integral will add a million, a billion, trillion of them up from -1 to 2. These are all going to be perpendicular to the x-axis, so the thickness is seen between my thumbs. So, Allie, is that a dy or a dx when you look?
It's a dx.
It is. So it's measured along there. Another way you might think of it is they're going to stack along the x-axis, so there are changes in x, very small changes in x. So we need to come up with, if this is a square, Allie, what is the area of any square?
Length times width, or just 2?
Yeah, length times width, and in a
2s.
square, if we called it s for side, it'd be side squared. So that's all we need here to finish the problem. The thing is, what is the length between my fingers here? Well, it started at the top function, and it ended at the bottom function, so it's going to be the top function minus the bottom function. So when we do that, we have the top one is the linear one, and then the bottom one is the quadratic one. And that's one side, so we have to square it. So a little slop here, but a little slop never killed us yet, so we can handle it. Let's clean up inside what I put as brackets before we square. So remembering the minus sign, we'll go to each function, each term behind it. Can you just simplify for me inside the brackets behind the integral sign?
It would be -x squared
Right.
plus x plus 2.
Right, and a plus 2. Unfortunately, we do have to square that. So if you could work on it in your paper, and I will put up what I got.
Isn't there something you can do as a shortcut for this?
No, not for when it's 3. 3 terms times 3 terms. You just have to distribute it every time. So take you a minute. So Bailey, you work on it at your place for squaring that trinomial. And here's what I got. I do need it confirmed before I integrate it, and once I did all the expansion. All right, we're about out of our 10 minutes, so we're just going to pause the video while we finish in class coming up with that, so we'll be right back.